Christian Jago, and I'm with
Rosely SOH
and we're gonna talk about the 6 trigonometric
ratios.
Let's begin! Have you heard the expression SOH CAH TOA? What do you think these expressions mean? In this lesson, we're gonna focus all about the right triangle, trigonometry.
Trigonometry is the branch of mathematics which deals with triangles, particularly triangles in a plane where one angle of the triangle is 90 degrees. Triangles on a sphere are also studied in spherical trigonometry. Trigonometry specifically deals with the relationships between the sides in the angles of triangles. That is, on the trigonometric functions and with calculations based on these functions.
Let's say this is theta. There's 3 sides of the triangle you need to be familiar with. So this is the opposite side. This one is the adjacent. And the longest right here is the hypotenuse. Remember the Pythagorean theorem? This indicates that the square of the hypotenuse is equal to the sum of the squares of the 2 legs of the right angled triangle. This is commonly written as C squared is equals to A squared plus B squared. In these 3 sides of a triangle, we should determine which is which. So the C means the hypotenuse. So this is the C, also known as the hypotenuse side. So this is the hypotenuse side. It's also known as the longest side among all of the 3 triangles. Next is the A, which means adjacent. So we're going to place A, the base of the triangle. This is the adjacent. And B squared. Okay, let's tackle again. C is the hypotenuse, A is the adjacent, and B is the opposite. Okay, in these 3 terms, let's tackle each one of them. So first, let's go here, the SOH, also known as the sine ratio. This is usually recalled as the SOH acronym, which stands for sine equals opposite over hypotenuse. This implies that in a sine ratio, we are only taking into account the opposite side, and this implies that in a sine ratio, we are only taking into account the opposite side and the hypotenuse. The CAH. This is usually means the cosine ratio, which implies the cosine ratio deals only with adjacent and the hypotenuse. So next we're going to tackle this expression. This is the tangent ratio. And this implies the tangent ratio, which is this, and it deals with the opposite and adjacent side. Key points. S stands for sine O stands for opposite. And H stands for hypotenuse. C stands for cosine. A stands for adjacent. And H stands for hypotenuse. T stands for tangent. O stands for opposite. And A stands for adjacent. Let's go to its reciprocal. So what is the reciprocal of the sine ratio? So its reciprocal ratio of the sine is cosecant, which stands for CSC. But when we say about the sine, its opposite is above and the hypotenuse is below. So while in cosecant, we switch both of these. So which means now the hypotenuse is above the opposite. Okay, let's go to cosine. So we remember that the reciprocal of cosine is adjacent over hypotenuse, right? While its reciprocal is the secant, which stands for sec and a. So when we say cosine, the adjacent is above hypotenuse, while here is the opposite. Hypotenuse is above adjacent. So we remember the tangent, which deals with opposite and adjacent. So what is its reciprocal? So the reciprocal of the tangent is the cotangent. Which means cot is equals to C tangent, while the cotangent is its opposite is below the adjacent. Let's solve. C squared is missing, so this is our constant term. We're just gonna copy it. Equals adjacent square. What is our adjacent? Yes, correct. Number 3. 3. Plus B squared. What is our B? Correct. The opposite, which is number 4. So we're just gonna copy it. B3 squared is equals to, correct, 9 plus square. The square of number 4, correct, it's 16. So just gonna copy again. 9 plus 16 is equals to, that's 25. Then we're gonna find both of their square root. So just cross this out. So C is equals to the square root of 25. Right, it's 5. So we found, or we figured out, the missing number of this hypotenuse, or the longest side of the triangle. Use the Pythagorean theorem to find the missing hypotenuse. We haven't finished solving our problem, so we're going to look for these. The sine, the cosine, and the tangent. Remember what I just said earlier. So, when we're looking for the sine, we deal with the opposite and the hypotenuse. So, what is our opposite? Correct, it's 4. How about our hypotenuse? Correct, it's 5. Next, the cosine. So when we're looking for the cosine, we must be able to see the adjacent and the hypotenuse. So what is the adjacent, the number of adjacent of this triangle? Correct, it's number 3. How about its hypotenuse? Correct, it's number 5. Next, in tangent, when we're looking for tangent, we must have the opposite and the adjacent numbers. So we got, right, 4, the opposite, over our adjacent, yes, number 3. So after we've unlocked the 3 trigonometric ratios, now we're going to look for its reciprocal. So what is the reciprocal of sine again? It's cosecant. So all you need to do is to flip 2 of these. Just 5, 4. Very simple, isn't it? The reciprocal of cosine says that. So I'm going to flip it through. 5, 3, and the reciprocal of tangent is its cotangent. So we're just going to flip it to 3 and 4. So here's another example. The length of a leg and the hypotenuse of a right triangle are 6 centimeters and 10 centimeters. Respectively, find the length of the other leg. So, what's the solution? Wrestling, come in. So maybe demonstrate to us what does the triangle, right triangle look like? So here's the right triangle. So we're looking for the leg. So what is the leg? Basically, it's the base of a triangle, which is six centimeters, and the hypotenuse of a right triangle is here's the demonstration of the right triangle. So in said question, we're going to find the length of the other. So we're looking for the opposite side of the triangle. So we're gonna use the Pythagorean. Yes. So let's begin. The first step is we're going to do what looks like. What is Pythagorean theorem? Looks like c squared is equals to a squared plus b squared. Correct, it's 10 centimeters. To equal, please. Equal. Thank you. So our adjacent is 6 centimeters. So we will read 6. Plus. So our opposite is constant. So we're looking for the opposite side. Square, the 10, the number 6, or the hypotenuse and the adjacent. May you do it for me, Leslie? So after last week of slow fix, we're going to find this. So 100 minus 26 is 64. Equals square. Then we're going to square the lead, so 64. So the square root of 64 is A, and the B squared is B. So here is our final experiment. Now we're going to find the 6 trigonometric ratios. The opposite, here the triangle. So we finally completed. So now we're going to find the 6 trigonometric ratios. Isa na yung packet and packet. Isa na yung packet. So, we copy the sign. So here's the first sign, which is reciprocal. Possession. Cosine is reciprocal. Second, tangent is reciprocal. So, since 8 centimeters is opposite, so we're going to place up 8, and the hypotenuse is 10 centimeters. Also, the possession, just flip it over, is at 8. Since these numbers have common, so we have the GCF. So 8 divided by number 2 is 4. While 10 divided by number 2 is 5. So here it's GCF is number 2. So divided by number 2, so 6 divided by 2 is 3. Then also so we divide to number 2 is 5. Also here 8 divided to number 2 is 4, and 6 divided to number 2 is 3. So also here they're the same though, but we just flip them over. Both of them have the same answers. We have to just flip two sides. So also both of these, the non-reciprocal and the reciprocal, have the same answers, just flip through. So this is the discussion about the SOH CAH TOA, or the 6 trigonometric ratios. Thank you all for watching our videos. May the participants. Let's say goodbye to our viewers. Bye!